And that was the case today concerning Mount Rainier.
In the event of a volcanic eruption at Mount Rainier.
Well, it was definitely the talk of social media on Wednesday morning. Some panic over Mount Rainier.
The Pacific Northwest, where clouds coil around snow-shrouded summits and the forests run as deep as legends, has always guarded its secrets well. But now, Mount Rainier, icon of Washington, crowned in ancient ice and mystery, may be forced to yield its most astonishing secrets yet. In the early months of 2025, a convergence of technology from above and science on the ground shattered the calm. Advanced satellites, trained to monitor everything from volcanic gas signatures to subtle ground deformation, captured anomalies so faint and so widespread they easily escaped notice until now.
Miles around, the mountain is an active volcano, part of the Cascades, which on average sees an eruption 1 to 2 times every century, somewhere in the range.
Rainier's last magmatic eruption was about 1,000 years ago.
When these images were pieced together, they revealed subtle signs beneath Rainier's slopes, networks, patterns, and seismic signals hinting at increasing volcanic activity and previously unobserved dynamics. Meanwhile, as leaves at treeline blushed with enigmatic early shifts, and trail cameras caught flashes of unusual animal movements, reports swirled on mountaineering forums, drone malfunctions near the summit, rope teams spotting ash-dusted icefall debris, and newly installed barriers along once stable routes. All this buzzed against the backdrop of a new spaceport being developed on Mount Rainier's summit, the first of its kind atop such a storied peak, advocated by Amazon, now a primary operator. Rainier, silent but swelling with power, has become the focus of an unfolding story that stretches from the forest floor to the edge of the stratosphere. How deep does the mystery beneath Mount Rainier go? What have satellites and those daring to venture close truly uncovered? Let's journey layer by layer into what may be the most remarkable discoveries ever made beneath an American volcano, and what it could mean for the millions living within its shadow. A mosaic of movement, ground, deformation, unearthed. It began quietly, volcanologists picking up conversations about subtle ground deformation patterns appearing and disappearing in recent interferometric satellite data. These state-of-the-art satellites, employing advanced radar technology, had targeted Mount Rainier for routine monitoring as part of long-term hazard assessments. But in early 2025, the images they returned broke the monotony.
Here in Washington, we have our own volcano threat in the Cascade Mountains, which on average erupts once or twice every century.
The threat includes Mount Rainier, which scientists continually monitor for activity.
Mapped in astonishing resolution, segments of Rainier's flanks were seen to be flexing slightly, forming swells and depressions that moved with the seasons. But in January, suddenly shifted direction. The deformation waves weren't random. They pulsed outward in broad, concentric circles, almost as if following a hidden logic beneath the earth. At the same time, linear fractures aligned with surprising regularity, stretching from Rainier's upper glaciers down onto the old-growth slopes below. Teams from the USGS scrambled to deploy mobile GPS sensors, but the satellites had already captured a time lapse of terrain shifts never before documented at Rainier. Of particular interest, a noticeable bulge beneath the summit ice, sudden and significant, raising concern among longtime researchers. Data suggested a deep pulse of magma, pressing upward, inching the rock and ice skyward. Shortly after, climbers ascending to Camp 2 found new cracks along familiar traverses, crevasses with unusually straight edges and a hint of fresh ash. Drones dispatched for close aerial inspection reported localized heat rising from fissures, and some lost contact entirely near the summit, inexplicably vanishing from telemetry. In local coffee shops, scientists debated over maps and printouts, highlighting how the bulge seemed to connect directly beneath the ice cap, a signal, perhaps, of changes deeper within the volcano. For those who remember past steam blasts, or even Mount St. Helens eruption in 1980, these signs felt both new and eerily familiar. By mid-February, tremor activity increased, not large enough to be felt on the surface, but distinct enough to register on sensitive instruments across the Cascade Range. These low-frequency quakes, known as volcanic tremors, are typically caused by fluid, often magma, moving underground. Their rhythm was unmistakable. Something was stirring. Gas monitors began detecting rising levels of sulfur dioxide near the crater rim. This gas, often one of the earliest indicators of magma rising toward the surface, pointed to new volcanic degassing. Snow around certain vents showed accelerated melting, and a faint scent of sulfur hung in the air, subtle but undeniable to those who knew what to smell for. Most telling of all, thermal cameras revealed that the summit was warming, not drastically, but enough to break the seasonal pattern. Sections that should have been frozen remained oddly exposed, steaming gently under overcast skies. Is Rainier swelling as part of its ancient volcanic rhythm, or is something distinct building beneath its crown? What's behind the remarkable alignment of terrain shifts and fissures sprawling across its slopes? Could this be the beginning of a new phase in Rainier's complex life cycle, or an ominous signal we can no longer afford to ignore? Volcanic signals, tree leaves, and tremors. On Rainier's wooded flanks, keen-eyed ecologists noticed changes now confirmed by multispectral satellite images. Trees at treeline began to shift colors weeks ahead of normal, their pigments changing due not to season, but chemical stress, consistent with the infiltration of volcanic gases such as sulfur dioxide. From above, satellite imaging revealed broad rings where leaf color faded in patchy mosaics, tracing around fissures and along drainage lines. Micro-drones sent in for plant samples confirmed what many only suspected. Rainier was exhaling, releasing subtle plumes of gas that stressed its surrounding ecosystem. Aerial spectrometers tracked fugitive emissions, imperceptible to most, but obvious to those seeking warning signs. Wildlife patterns also shifted. Trail cameras documented elk and deer streaming away from the upper slopes, herds moving quickly and in odd clusters, while rock-dwelling marmots and pikas became strangely scarce. Rangers recounted unusual silences, birds falling quiet on select mornings, contributing to an unsettled feeling among those who worked the land. Rescue teams discovered abandoned burrows and uneaten forage, a sign of hurried animal departures. At night, pressed grass and side trails hinted at nocturnal migrations hidden from the day. Indigenous elders, invited to consult, recalled stories of animals leaving before volcanic fire, an old wisdom suddenly relevant in modern times. But then, science provided measurable proof. Seismic sensors and satellite data together confirmed a striking pulse. On a single day, over 10,000 micro-earthquakes rattled Rainier and the nearby valleys. While most went unfelt by humans, early morning hikers, especially those arriving on January 19th, described a rolling vibration beneath their feet, a restless mountain murmuring beneath its ice. Seismologists analyzed the data, finding a tangled web of tremors radiating from under the glaciers. Some likened it to the breath of a sleeping giant, as subtle harmonic tremor patterns, known to sometimes precede volcanic movement, were seen in the records. In meeting rooms, from Seattle to Tacoma, experts debated if this seismic swarm signaled shallow magma movement, excessive gas release, or a new process at play within Rainier's deep structure. In the following days, shallow borehole sensors picked up localized pressure spikes, brief but notable. Scientists also recorded changes in groundwater chemistry downstream from the mountain, especially elevated chloride and sulfate concentrations. These can signal hydrothermal fluid migration, a process typically hidden unless the subsurface plumbing begins to shift. Park staff began rotating emergency drills for visitor centers and trail crews. Signs were updated, quiet notices were posted at ranger stations, and overnight camping permits were quietly restricted above certain elevations. Could the early tree leaf color changes, restless wildlife, and an explosion of thousands of tiny earthquakes all be part of a larger volcanic narrative? Was the volcano sending out unmistakable signs, recognizable both to ancient traditions and modern satellites? And if so, how long before the next signal comes, not as a whisper of leaves or the silence of birds, but as something louder, closer, and far less subtle? The summit's new crown, Spaceport Amidst the Clouds. A unique chapter in Rainier's modern story is the construction of a spaceport at its summit, an ambitious project championed by Amazon and now in an advanced stage amid the clouds. The concept itself unsettled many, a major aerospace facility atop a potentially active volcano. But the project advanced, transforming the skyline. Satellite imagery now revealed gleaming structures perched on the summit. Metallic frameworks and launch platforms cut bold lines across the ice cap, while modular facilities housing both crew and equipment blended with the harsh alpine landscape. From space, these installations appeared as geometric constellations, ordered, angular, and standing out starkly under the ever-moving sky. Thermal images caught heat signatures from machinery, and corridors kept constantly thawed amid glacial ice. Ascent routes formerly used by climbers were diverted. Ropes once leading to Camp 3 skirted new cables and warning posts. Hikers recounted turning back at unfamiliar barriers, finding old trails now redirected or temporarily closed. Drones and supply vehicles traversed the mountain, ferrying materials for the project, while environmental teams maintained vigilant monitoring of local snowmelt and ice stability. Scientists logged comprehensive environmental metrics, mindful of fuel residues and other markers, recognizing the delicate balance between innovation and environmental stewardship. But tensions ran deeper than logistics. Local communities, environmentalists, and indigenous groups raised objections, warning of spiritual disruption, ecological risk, and the unpredictable behavior of the mountain itself. Petitions circled, lawsuits were filed, yet construction pressed forward, supported by powerful lobbying and framed by the vision of Rainier as a gateway to low-orbit deployment. Most provocatively, satellites observed that the spaceport sat near the area of greatest ground deformation, the summit bulge and its dynamic subsurface. Experts weighed the risks and implications, a symbol of ambition built atop a restless volcano, where the ground beneath could shift in ways human plans could not anticipate. Deep-bore sensors buried by the USGS near the launch pads began picking up faint harmonic tremors, subsurface vibrations consistent with magma movement. While not immediately alarming, their proximity to heavy construction and potential launch-related shock waves ignited a new layer of concern. In one confidential report, scientists questioned whether vibrations from future launches could interact with existing fracture zone or pressurized pockets beneath the summit. Could supersonic acoustics, blast pressure, or sheer weight load influence geological pathways already stressed by deep magmatic motion? Publicly, Amazon executives maintained that the facility was safe, sustainable, and symbolic of human progress. But behind closed doors, a different tone emerged. Emergency evacuation routes were drafted. Contingency plans considered launch delays during periods of volcanic unrest. Drone footage was quietly scrubbed of certain anomalies, steam jets, heat signatures, faint surface cracks. Could launching rockets from such a site influence or be affected by volcanic rhythms? Or does the technology merely coexist with one of Earth's most formidable natural powers, both realms operating in uneasy parallel? And if one day Rainier reawakens, will it do so beneath the rocket fuel and scaffolding of human ambition? Or will the mountain remind us, once again, who truly holds power beneath the sky? Shadow below the ice, patterns and anomalies exposed. Perhaps the most profound images came from satellites equipped with ground-penetrating radar and gravity sensors. These passes, sweeping the peak in careful tandem, detected faint structural differences extending for kilometers beneath the summit. Beneath the snow and ice, layers of fractured rock formed concentric rings, their patterns repeating to previously uncharted depths. These rings, in several instances, overlapped with pronounced fissures on the surface, revealing a direct relationship between subsurface forces and visible geology. The radar exposed vaults of older volcanic material, frozen remnants of long-past eruptions, and suggested the existence of extensive hydrothermal alteration zones below the cap. Microphone arrays coupled to satellite sensors detected faint reverberations in the mountain's interior, suggestive of moving fluids, migrating gas, or occasional minor rockfalls deep within. In the area below the new spaceport, sensors outlined a possible large cavern system. In places, these spaces appeared to have collapsed or been bisected by fresh faults, a reminder of the dynamic processes at work out of human sight. Some instruments recorded minor magnetic anomalies near these voids, possibly indicating zones rich in magnetite or other minerals associated with ancient eruptive activity, while a few geophysicists speculated about rare mineral phases or unusual electrical properties. The evidence remains grounded in natural geological processes. Could Rainier's roots indeed be laced with ancient networks of cooled lava, hydrothermal veins, and shifting water? Is the mountain's deep anatomy now being mapped in the finest detail only thanks to unrelenting satellite monitoring? Ash on the wind, sudden change, and human reaction. As satellites traced patterns imperceptible to the naked eye, those on the ground experienced unmistakable evidence of change. January 19th, especially, stands out in collective memory. Climbers and rangers setting out from the dense, wet rainforest arrived to find the familiar snow dusted in gray, the air tinged with the faint scent of sulfur. Reports of icefall collapses came rapidly. Upper cliffs broke loose without much warning, their collapses echoing down valleys. Ropes strung along the ascent routes were found snapped, covered by debris, while teams at Camp 2 observed slushy flows laced with ash moving through formerly stable crevasses. Park medics treated hikers for respiratory complaints and eye irritation. Water sources were checked and sometimes rerouted, with teams wary of possible contamination from the sudden influx of volcanic residue. Wildlife staff watched as GPS collars on mountain goats showed unexpected movements, the animals wandering far from their typical ranges. At ranger stations, seismometers flickered with continuous signals, registering the ongoing microquake swarm. By evening, over 10,000 earthquakes, almost all small, had been recorded in just one day. The USGS issued advisories urging all but essential personnel to avoid the upper slopes, and search and rescue teams sought out missing drones and data loggers. Around the world, remote cameras and news feeds showed Rainier's upper clouds shimmering with subtle changes, the summit banded in stripes of uncertain gray and white. Social media, always quick to amplify local drama, filled with stories, photos of boots splitting fresh ash cracks, flocks wheeling away out of season, and trail closures popping up with little notice. Satellite thermal readings indicated rising vent temperatures, enough, say some, to accelerate snowmelt and pose challenges for communities below. Is Rainier warning of an awakening in coming months or years? Or are these merely the signatures of a restless but not erupting titan? For locals and scientists alike, the question is no longer if, but when. The mountain's story will take its next chapter. An unnatural geometry, glacial and subsurface patterns revealed. Among the more curious satellite discoveries was a set of geometric alignments traced across Rainier's glaciers and subsurface. While glaciers typically flow in seemingly chaotic curves, images from above revealed surprising linearity, subtle, straight-edged ridges, and intersecting grooves. On closer inspection, ground-penetrating radar revealed subglacial voids running for hundreds of meters, many beneath the most angular of these ice ridges. Geologists suggested these might be relics of past glacial lobes, held in place by local topography or tectonic features below. The possibility exists that older lava tubes, now partially collapsed, contributed to the distinctive patterns seen on high-resolution images, while some speculated more wildly about ancient engineered environments the prevailing explanations remain within the bounds of geological phenomena, landslide scars, ice flow constrained by bedrock fractures, and self-organizing mineral structures. Still, digital elevation models showed some features resembling concentric circles or arcs, scrolls of landscape history inscribed in ice and stone. Researchers used computer simulations to model energy flows and water movement along these features, searching for clues to their persistence. The findings may help explain how Rainier's ice and rock interact, focusing stresses and channeling meltwater in unexpected ways. Are these alignments merely geological handwriting, the result of deep time and restless forces at work on a volcanic mountain? Or do they suggest that nature's patterns run deeper than previously imagined? A living enigma, what lies unseen. As the revelations of 2025 multiply, one after another, the legends of Mount Rainier, born of ice, cloud, and fire, find echoes in reality. The summit bulge, the shifting substrate revealed in satellite maps, the visible signals of forest and animal life, and the silence turned suddenly loud, all speak to a volcano alive beneath its beauty. From pioneer climbers to modern engineers, those drawn to Rainier have always sensed its dual nature, majestic but unpredictable. Now, new satellites and sensors have exposed layered truths, that beneath the peak lies a shifting world, its patterns only now revealed, dynamic and mysterious. Are these discoveries the beginning of a transformation or a prelude to events still unforeseen? Will satellite data and the wisdom of those who watch close by be enough to anticipate what the mountain holds in store? Through new eyes and old, the truth remains clear. Rainier is not merely a monument, but a living question mark. Tell us below, which of Rainier's unveiled secrets haunts you most? The uncanny quake swarms, the hidden geometry, the new frontier above the clouds. Hit like and subscribe for more astonishing unravelings from the edge of our planet. And remember, sometimes the greatest mysteries are not in distant galaxies, but just beneath our own feet. Until next time, keep questioning and keep watching the mountains. The next story could rise with the dawn, where Earth meets sky.